In this video, we're going to answer several questions about a rational function. We are going to state the domain of the function. That's part A. We are going to identify all the intercepts. That's part B. Part C, find any vertical and horizontal asymptotes. And part D, plot additional solution points as needed to sketch the graph of the irrational function. So our function is c of x equals 5 plus 2x all over the quantity of 1 plus x. So if you remember back to a previous video, we talked about the guidelines for analyzing rational functions, and make sure you're okay with the idea that, okay, so step one, simplify f if possible. And notice that in this problem, there is no simplifying you can do. You cannot cancel out these x's, for example, because this x right here is a term and not a factor. All right, so let's first deal with the domain. So with your domain, and actually, when you find your domain, you want to do that right away and then deal with the simplifying. But anyway, like we said, this one doesn't simplify at all. So with domain, remember that when you're dealing with fractions, you can never divide by 0. So any value of x that would set this denominator equal to 0, we want to eliminate as part of our domain. And when does 1 plus x equals 0? Well, that would be at x is equal to -1. Now, that's the bad value. That's the value that's not part of our domain. Any other value of x will work here except this -1. So we're going to say our domain is the set of all real numbers except x equal to -1. Part B, find the intercepts. So remember, when you're finding x-intercepts, if you're ever confused, just think back to your graph. This is your x-axis. Every x-intercept is going to be on the x-axis. And when you're on the x-axis, you didn't move up or down. In other words, your y value is 0. So always with x-intercepts, set y equal to 0. And with y-intercepts, it's the other way around. If you're on the y-axis, you need to make sure that your x value is 0. So we're going to set x equal to 0 over here. So with our x-intercept, set y equal to 0. Remember that with function notation, c of x is the same thing as y. So we're going to have 0 is equal to 5 plus 2x all over 1 plus x. And the only way that this fraction is going to equal 0 is if the numerator is equal to 0. If you want to, you can think of multiplying both the left and the right-hand sides by 1 plus x. But all we're going to have here is just 5 plus 2x equals 0. And from here, subtract over your 5. So 2x equals -5. Divide by the 2. X is equal to -5 halves. So we have one x-intercept, and that's at -5 halves. With our y-intercept, we're going to set x equal to 0. So that's basically the same thing as saying, let's evaluate our function at 0. So c of 0 equals 5 plus 2 times 0 all over 1 plus 0. And let me get rid of this mark here. 5 plus 2 times 0. Well, 2 times 0 is 0 plus the 5 would be 5. 1 plus 0 is 1. 5 divided by 1 is 5. So my c of 0 is just 5. And that's my y-intercept. Part C. We're going to deal with now the vertical and horizontal asymptotes. So remember that when you're dealing with vertical asymptotes, you are going to just set your denominator equal to 0. And in this problem, this matches up with our domain. In some problems, you might be able to simplify this so it won't match up perfectly with our domain. But there's nothing to simplify here. So we're just going to take our denominator, set it equal to 0, and solve. And as we got before, not only is x equal -1 not part of our domain, but it's also where our vertical asymptote is going to be. Our horizontal asymptote. So let's look at these degrees. So the degree of the numerator is just 1. The degree of the denominator is also 1. So notice your degrees are exactly the same. So here, I'll make a note of that. Degrees of numerator and denominator are the same. So take the ratio of your leading coefficients. Leading coefficient up here is 2. Down here it's 1. 2 over 1 is just 2. So we have a horizontal asymptote at y equals 2. The only thing left is to create our sketch. All right, so if we look back here, we know that our domain is everything except x equal to -1. We have this vertical asymptote at x equals -1. So all I'm going to do is just draw in my vertical asymptote right here at -1. Bear with me here. I'm trying to go as straight as possible. Okay. And next, we have our intercepts. We have an x-intercept at -5/2, so that's at -2.5. So there's that x-intercept. And our y-intercept is at +5. So let's plot that. Yeah, okay. All right. So I dealt with this page. So now I got to deal with my horizontal asymptote at y equals 2. So let's get a nice dotted line in here at y equals 2. So there's my horizontal asymptote at y equals 2. Okay. Now, the last step here is to basically plot these additional points. And I'm going to go through this quickly. So as we do this, just evaluate the function at some different values of x. So for example, one thing I want to do is I want to figure out, what's happening out here to the left of this y-intercept. So pick something to the left of this -2.5. I'm going to choose -5. So let's plug in -5 for x. And if I plug that in, run that through your calculator, you should end up at 1.25. So here, let's talk through that real quick. 2 times -5 would be -10. -10 plus 5 would be -5. So I have -5 in the numerator. And 1 plus -5 is -4. Those negatives would cancel each other out. 5 divided by 4 is 1 1/4, or 1.25. So I'm going to go left 5, up 1.25. So I'm about right there. Okay. So next, let's find out what's happening in between here, in between this x-intercept and this vertical asymptote. So let's plug in, you can plug in -2, or if you want to get closer, you go -1.5. I'm just going to go with -2 here. So let's plug in -2 for x and run that through. 2 times -2 would be -4. -4 plus 5 would be 1. So that's my numerator. 1 plus -2 is -1. And 1 divided by -1 is -1. So 1.25, we have -1. What was our point again? Our point was -2, -1. So we're about right there. All right. Now that I have these points, I can kind of get the general idea of what's happening to the curve. And if you're ever not comfortable, feel free to plug in more points. I'm just going to try to draw this curve the best that I can in here. It's going to do something like that. And as I go down this way, and your sketch doesn't have to be perfect. We're just looking for a rough sketch. By all means, like I said, feel free to plug in some more points here. The more points you get, the more accurate of a curve you'll have. Let's get a couple more. So in between this vertical asymptote and this intercept right here, this y-intercept. Let's just see what's happening at -1.5. So we can plug in that part. So if I have an x value of, I think I just said -1.5, just -1/2. If you plug in -1/2 for x, 2 times -1/2, so half of 2 would be 1, with a negative in there, that's -1, and then 5 plus -1 would be 4. That takes care of our numerator. And 1 plus -1/2 would be +1/2. And remember, if you divide fractions, you multiply by the reciprocal, or you can just think this through in your head. If you have 4 and you divide it into groups of a half, there's going to be 8 of those groups. So this is going to be +8 right there. So I have the point -1/2, comma 8. So that's about right there. And let's get one more point over in this direction. So let's go way over here to the right. Let's go with 5. We'll plug in 5. And if I run 5 through this, 2 times 5 is 10. 10 plus 5 is 15. And 1 plus 5 would be 6. 15 over 6 would be the same thing as 2.5 or 2.5. So, 12/6 would be 2. And with the extra 3/6, you'll have a half there. So 5 comma 2.5. So 5 comma 2.5, you're about right there. And now I get the general idea with this part of the curve. Try to connect my dots. Let's try again. Okay, I'll start here. Go up that way, and there's my sketch.